So I will continue. So objects cannot and should not be accessed directly. So if you go in and look at one of these objects with an hex editor, so you, for instance, can use hex dump to see what is in it, it will look something like this. So you will not look at these directly. But you can observe the type and the content of an object with these commands here, git cat file -t for type, or -p where it's printing out what is inside of it. So let us try do this. -t, and then we will find this one here, and we can take just the first part of it because we have very few objects. And when we're in that situation, it is very unlikely that you will have any that have an hash that is similar enough that it is a problem. So we can just take the first part of it. And remember, these two letters here, two characters here, that are shown as the directory, they are actually part of the hash in this way. This is how Git arranges it. So you copy this, and that should be enough because we have so few objects. So we are copying this like this here. And then we are told that it is a blob. And a blob is what Git calls files. So let's change it to -p. And then it prints out the content of this blob, this file. And it says, this file is very interesting because this is the content we put into the file before. It's also important to realize the object stays even when the file is removed. So let's try remove this file1 or file.text like this. And then I'm doing find. And you can see here, this is the object. It is still there. And you can still look into it if you want to. So, but you can see the file did not go away. And we can also restore the file from the object. So we can do git restore file text. And then we have it again. And we can check inside of it. So Git keeps a history of everything. Let's take a look again at the repository. We had it before here. And you can see there are two more objects. So this one here is the content of the file. What are the two other ones? And those you saw also here. So let us see what is inside of them. We can take a look at this one here. We say git cat file -t, and then we go up and pick this one here. Like that. Again, remembering to include the two first characters. And then we see it is a tree. So let's see what's inside of this tree. There's a file.text. So here we see the type of the object is tree, and there are inside of trees there can be files, blobs, and other trees. It stores pointers to that. And trees are used to represent directory structures. In this case, the tree has one level and one blob. There is one file in this tree. Again, we are looking at the repository. We still have one object here. So let's see what is that. And let's see if we can find it. The thing is, I will just do find again. And it is here, it is named like this because, well, it has more content. I mean, I added another file and things like this. than I have in this example on the slides. So let's say git cat file -t. Let's see what this is. Oh, it's a commit. Oh, it had to be. We knew there would have to be a commit as well. And let's see what's inside of this commit. That is the very first commit we made. So now we have seen that the tree has, there is a tree itself, there is an object, and the object is a blob, and there's an object that's a commit, and there's an object which is a commit itself. So it has a pointer to this tree. It has an author and a committer that you can see here. Here's the tree and its hash. There's an author, that's me, and I also have committed to it. The reason there's both an author and a committer is that someone created the file, and then when you make changes to it, it will be committed, so you will list it as this is the person that committed to it. And it will also have time, and it will also have the message itself. A commit stores the state of the project at any given point of time. And in this case, the commit points to a tree that has one level and one blob, just as we saw. In a more general case, the associated tree can have several levels and multiple blobs. So here we see how it looks. I mean, we have, this is the repository structure, the folder. We have the repository itself, it's a tree. And we have the files, 1, 2, 3, 4 here. They are blob 1, 2, 3, 4. The directory is a tree, so it's a tree here. This is also a directory, and it's also a tree. And the metadata for this is that it's a commit. So when we are working with Git, let's see some more of what we can find, because there are many other things that are important when we are working with Git. So we have head, and we have refs and heads and master, which is in this case the name of the branch. And the head points to this commit here. And remember, the commit in this case is this hash instead, because we have a different example than the one that I have here on the slides. But let's try and do a cat of this here. Remember, cat is a command that outputs the content of something. And here it says that the head points to this ref's head's master. So let's take a look at that. Okay, so you know it's under Git. This extra dot here is not necessary. It just says that it is starting from that directory, so from this one, but it's not necessary. So we are going and look in this here, and there we get the hash. So you can see here, as expected, this is the hash we had up here for the commit. So head and master are references. A reference points to commits and to another reference. Head, there are many commands that act on the current head. And the head determines the most recent commit. And I will talk more about head, and later in the course we also will talk more about head. It is a very important reference. Master is the current branch. Remember, in some cases it would be called main, depending on what you choose, and on GitHub it is usually called main. It is, however, completely configurable. You can call it what you want. It could also just be my branch. It's just important to use the same one for everyone in a project. So you can also create references yourself with git tag. And you could make a tag first, and then you will be able to find that also in the tree. So if I wrote git tag first, and then I do find, then you will see there is, let's see if we can find it. It's tags here. So you can see, here we have it. And we can also try this command here, git rev pass first. And again, it shows you what it points to. So it is another pointer to this commit message. So that is fine. It's as it should be. So you can see it points to the commit message. So let's look at some of the earlier steps. In the staging area, we have the file here, and then we have it here also. This is the blob for it here. So, and if we add some more stuff to it, let's do that. And this is a Linux command that should also work in Git Bash. And it is echoing the content you are just writing and forwarding it or sending it to this file here. So we can try output the file so you can see what has happened. You can see now it appended more content to it. And if I do find now, then you will see that there should be a change here. Of course, I forgot to stage it, add it. So I am going to add this file so that Git knows about it. And let's do find. And now there is a new object here because now we have new content. Okay, this is good. And we can again try do git cat file on this hash for this object. And we could try first do -t. So it was this one here. It's a blob. And let's make it print out what's inside of it. It is the content of the file. So it looks as it should. So the git add command, it creates a blob that corresponds to the updated file text file. There is no other objects created yet. We haven't made a commit for this, for instance, because we haven't written git commit. So there will not be an extra object that is a commit yet. It also adds a file to the index, and the index will become the next commit when we do that, when we do the commit. And it contains a representation of the tree object. The index itself is a binary file. And we can turn the index into the next commit, and we do that the same way as we otherwise will do a commit message, of course, because this is how it works. So we do git commit, and here we do it again in the short form, where we just say git commit -m and what we want in the commit message. This way we avoid opening the editor. It is a faster way, and it is mainly useful if you have short commit messages like this. And now we do the commit here, and we do find, and now we expect there to be a new object containing this commit here, and we find it here. So there is one. And it is just like here. It's just named different because we have more files, we put stuff into it differently. So I would like to do git cat file again. I'm going to do -t first, so you can see it's a commit. And then we are going to do -p on the cat file. And then we have the content of the commit. We have this tree here, the hash for it. We know here also what is the parent of it, what that points to. We have the author again, we have the committer, and we have the message in the commit. So it looks again as we expected it to. And yeah, just as there is a commit that describes the state of the repository too. We also have this blob. I'll just see if I can find it. Let's see. It should be this one. Let's see what it says, if I am correct. It's a file. And we can check here and see. Sorry, it's the tree and it has one file, namely file. And let's look at this. And here is the blob with the content. So the file itself. So the major difference is that the commit now contains a pointer to a parent, as we just saw here. And yeah, this is the parent commit of the commit we had. So we are now in this situation here. We have made a second commit, and it points back to the previous commit, and it points to the file as it is. And this is now the content of the file. The previous commit, the parent of this commit, it points to the file, to the tree here where the file is in, which points to the file itself as it looked at that point. So you can see for the first commit, this was the content of the file. For the second commit, this is now the content of the file. So we're building up this tree structure. And it points always to the previous commit, yes. Usually you will have a complete tree of commits or commit tree where you point backwards in time to how it looked at that time. And each of the commits points to a tree that also has blobs under it, files. And it, of course, represents the state of the repository as it was at any given point in time. And this fact that it points backwards to them, it means you can move back and forth in the tree, look at how your project looked at that time, which files were there, and things like this. And we will talk more about that when we comes to traversing the commit tree, which Diana will talk about. And each commit is allowed to have multiple parents. And that can happen if you have two or more branches that are merged, but we will talk more about this later. So head again, let's investigate it some more, and also the master. Let's see how it looks now. And see, it points to this here. Let's try look at it. And now we have this hash here. And that is the hash that it points to. Head points to the tip of the master branch, and that points to this commit that we looked at here before, this second commit, which is the newest commit. And in general, Git commands mostly work on the current head. That is what mostly happens. We can change the head to point to something else. And we do that by doing git checkout to an earlier commit. And our first commit, let's go up and find it. It was this one here. So let's try do git checkout on this commit. And the message you get here is that the head is now in a detached state. And that is something you often will see, a detached head state. And it simply means it's pointing to something else but the tip. And here you can look around, see this is, you go back and forth in the tree looking at it. There is no problems with this. And let's see what it points to. We do the git cat.git head. And we're told it points to this hash here, which was the one we switched to up here. So that's as we expected. And let's look at the file now. You can see the file now looks as it did at that point in time before we added more content to it. And we could now modify the tree and we could create a new commit. So let's try do that. I will try adding more stuff to it, to the same file again, like this. And I will now commit this. And in this case, I will use the shortcut, which is git commit -a -m. That does adding and telling it I'm going to use the short version of the short way to write a message. So I'm going to say git commit -a -m, and this is the third commit. And now it tells me two things. First, I did this commit here, but it also tells me I am in detached head state. And it tells me the hash for it, because now I added a commit, so now the detached head has moved. It is pointing to this hash. Let's look at it. This is the one that we are just told of here, so you can see here. Let's try do git cat file -t. It is a commit, as we expected. Let's see what's inside of it. The content of it is that this is the third commit. It tells us what the tree is. It tells us what the parent is, which is the first commit, the one we went to with checkout. And then it tells us that simply we are now on the third commit. So let's look at this. It looks like this. We are pointing to the first commit. And the tree also now has two branches, because remember, we still have this here, the second commit, but we moved to this point here, and then we did additions to the file as it looked and made the third commit. And now the file looks like this when we are standing and looking here. So how do we resolve this? Because now there are two versions of the same file. There are two branches. Well, let's name the second branch. We can do it that way. So we say git checkout -b second branch. And this command will simply create a branch and switch to it in one command. So we created a new branch, second branch, and we switched to it. Let's look at the head reference. It is pointing to the tip of the second branch. So let's look at this here. It has this hash, and this is the hash of the commit message, the newest commit for this branch, which is the third commit, the one we looked at here. And now all that happened is we have named this second branch here, and this looks like this. And we have still the master branch, which looked like it did before. Nothing has changed to that. But how do we reconcile these two branches? I mean, the file, possibly other files, would have been changed. In this case, only one file. Well, let's go and merge the branches. And let's see what happens when we do that. So we go to the main branch, to the master branch, and then we merge the new branch to it. So we do that with git merge. And in this case, I'm saying I don't want to use fast forward. Fast forward is the default way for Git to merge branches, but I'm telling it I don't want to do this in this case. Let's see what happened. It is trying to auto merge, and it gets a conflict. Of course, because you have different stuff in the same position, in the same file, in the two branches. And that means that we will have to fix this. And to fix it, we will have to do it ourselves. So I'm going to open the offending file, the one that now has conflicts. And it looks like this. There are these Git markers in it. It says on the head, the file looks like this. This file is very interesting. It's on both of them. On the head, now where that points to the master branch, the regular branch, the more content is what was there. On the second branch, instead, we had the line different content. They are both on the same line, so we will have to choose or do something else. And when we choose, what we do is we remove this line here. We will remove this line. I will also remind the divider between the two types, and then I will have to make a choice. What do I want to do to it? And in this case, I am just going to randomly choose to write it like this. I could pick anything. I mean, it is up to you to resolve a conflict. If it is a source code or something, maybe you really need to take a good look and see which one is the correct one. What do you want to keep there? But the same is the case for text files or many other things. Note now, by the way, that I'm using Vim. That means that in order to write in it, I have to push I to go to insert mode, and I have to press escape to go to command mode. And when I am in command mode, I can, for instance, write the file and quit it, which I do with :WQ. That is now done. I will now add the file. Like this, and then I will tell the merge to continue. And it is now merging the branch. It tells me here, and it has the history of the problems that were there. I'm just going to keep this message and go out of it. And then it tells me it merged the branch, second branch. There is no more conflict now. We can do git status, and it tells us this file 2 is untracked. It's not relevant. We were not messing with it right now. It was file.txt we were looking at. there were no problems with it now. So this is fine. This is just Git telling you you have a file you haven't told me about. But for now, we're just going to ignore it. We could just add and commit it. It would track it. So the newly created commit has two parents, namely the commits of the two branches, the commits at the tip of the two branches. And it is this commit that is now created. So let's take a look at it. First, I'm looking at the type. It's a commit. I will now see what's in it. It contains the text merge branch, second branch, because that is what we added. So that is fine. And let's see. How does the tree look now? The tree looks fine again. The head and the master points to the same. And we have this most recent commit, merge branch, second branch. And it points to all its parents. This is the third commit, this is the second commit. They are the parents of it. And it also points to the blob. That is how it looks now, the file. And in this case, it was resolved by just keeping it as more content and different content on 2 lines. I just added them to 1 line. It doesn't matter. It's just showing how it looks. So let's switch to a specific commit. You can always move back and forth to any of the previous commits and then back again. And then again, you would see the file as it was at that point. Again, it is, let's do find. And you can see, again, we have as it looked in the first commit, and we could go back to it again. We could do git checkout one more, like this. And now I am again in a detached head state. I will do git, I want to do cat file text and look at the file. It looks expectedly as it did at the time of the first commit. All that happened is that we moved the head reference to point to the first commit, and then we see how it looked at that point. And this is what I wanted to talk to you about here. So many of these commands that I have given here, they will be shown in these exercises that there are. And many of those will tell you also to look around in this .git directory and see. But let us go and look at the exercises. And if you cloned the repository, let's see if I can find it here. Where did I put it? I have not unzipped it there. But let's go and take a look at the repo here. And when you do a git clone of this, I'm just going to do it one more time to show you. And I will again clone this. Git clone. Takes a moment. Takes a little while. Okay, good. So let's go into this directory, and then you will find this file here, git materials zip. You used it just earlier for the basic commands exercises, but now I will unzip it, and then I will go into git materials. And here you will find there's a directory called 3 file.concepts. Let's go to that. Inside of that, there's a file readme. And yeah, the easiest thing is you can just open it like this. But it is an .md file, it's markdown, so you could open it inside of some sort of something like VS Code, some markdown reader, or if you have placed it somewhere on your home machine, then you could also open it in a browser, and it will show it somewhat nicer, but it doesn't really matter, you can read it easily here. Anyway, here are explanations to what you should do, the first exercise, the next second, and so on. I mean, the exercises are more or less the same thing as happened if you have typed along in this lecture here. One thing to make note of is that when you do nano file.txt, if you do nano on a file, for it to create it, you need to put something into it so you can save it. There are also answers to these exercises, just like for most of the exercises. If you go to this directory here, course intro git, then there is a directory exercises solutions. Let's see what's inside of it. And here you will find that for each of the sessions that has exercises, there is some suggested solutions to them. So you can go into basic concepts. If you read it as a markdown file, it will use these images inside here, or otherwise just open the PDF file. You will have to use your own PDF reader, but I have one that's called Events, but then there's it goes through the exercises. So, okay. So let's take some time to do the exercises, maybe 10-15 minutes, and you can write into the Q&A document if you have problems, and then we will come back to it.